Hi, my name is Muhammad Karim Mizan Bekanur Anwar, or people usually call me Mizan. So for today, I will be presenting on the topics of decision tree and naive bias for sentiment analysis in smoking perception. Okay, the presentation outline for today. Firstly, of course, is the introduction on why we do this study. Next is the materials and methodology used in this study. Afterward, I will show you the computational results, and in the end, I'll show you what we conclude from our findings. Alright, first we jump to the introduction. So, the number of smokers is still significant in many countries, and also many countries want to reduce it since less smoking habits leads to healthier people, and healthier people means healthy mind, thus it will later contribute to the well-being of the nation overall. The trend of smokers has seemed to keep changing in time, especially in Malaysia. Previously, people been only smoking cigarettes or cigars, but then there's the existence of the shisha or hookah, and the latest trend is the e-cigarettes or the vape. Despite the rise of these new smoking trends, a smoke-free nation is still one of the aims by 2045. Thus, there is a need to see the trend of smoking as it can be one of the assistance to the relevant agencies to track the smoking trend. Perceiving the sentiment of smoking is now possible instead of utilizing the traditional approaches like doing surveys, conducting interviews, and questionnaires, these are popular methods for identifying current smoking trends. These approaches require time, cost, and a lot of field work. Thus, in parallel with digitalization and Industrial Revolution 4.0, the trend analysis methods are established in many forms, such as Twitter, website, and Facebook. Due to that, this paper's focal point is to see the utilization of decision tree and naive Bayes to perform sentiment analysis on smoking perceptions in 3 states in Malaysia. Alright, move forward to the methodology. So the picture or the diagram in the presentation currently showing what we did in our study. Firstly, what we did is we scrape data from Twitter. We extract all tweets which were related to smoking by using one or two word search term. One word search term, the example is smoke, cigarettes, while two word search term is something like smoking, love smoking, like cigarette, and love cigarette. The purpose of the search term is to increase the relevancy of the data that has been collected. This will make it easier to process and categorize the tweets according to their priority. It also will make it easier for the process of analyzing the tweets later. So for the data that we scrape, it involves either English or Malay tweets. However, this paper will only be focusing on the English datasets. During data acquisition phase, we will get the raw data which later will be pre-processed during the data preparation phase as per in the diagram in order to get a clean data set. What we did to get a clean data, you can refer to the diagram, which is we will remove link address, hashtag, mention, duplicate, remove numbers, special characters, emojis, emoticons, stop words, and later on we do tokenization, stemming, and labeling. This data processing work purpose is to convert the data into something that a computer can understand. We also classify each of the data tweets into 3 categories of polarity, which is either positive, neutral, or negative. Once we have the clean data classified, we did feature engineering with n-gram. N-gram is a sequence of n items widely used in natural language processing to convert the raw text into features that can be processed by a machine learning classification algorithm. After that, we'll be using naive Bayes and decision tree classifiers to classify the polarity of each clean data that been used for this study. Alright, here is the data we acquired. So from the data that we acquired, we already classified it into 3 categories, which is either positive, neutral, or negative. So this is number of the tweets based on one word search term and 2-word search term or tweets. So yeah, these are the clean data sets. Alright, we come to the computational result. So this is the result for the 1-word search term, either using naive Bayes or decision tree. As you can see, for the results, what we can see for the accuracy of shows that decision tree have higher accuracy compared to naive Bayes. However, naive Bayes is quite decent or quite good at predicting the positive tweets for the smoking data. While we can see as for decision tree, they are also quite good at predicting positive tweets. However, and predicting positive tweets and negative tweets, but maybe not really at the neutral tweets. And then for the accuracy, of course, higher, then yeah, it's also have a higher recall for the positive tweets. However, the recall result for the decision tree is quite low compared to quite low for the neutral and negative tweets compared to the naive Bayes. Alright, next is the computational result on the 2-word search term tweets dataset, tweets or datasets basically. So yeah, it's comparing between naive Bayes and decision tree at 4 different split ratios. So from the result provided here, it is interesting that naive Bayes actually outperforms the decision tree in all aspects. Even the lowest accuracy of naive Bayes is higher compared to the decision tree. The highest accuracy of the validation is almost 65%. It is when using the naive Bayes model with a 0.9 split ratio. The accuracy probably is not that high, but it shows that naive Bayes is only bad at predicting positive tweets. From the results, naive Bayes is very good at predicting negative and neutral tweets. It has 100% precision when predicting negative tweets at all 4 split ratios. It also achieved 100% precision in predicting neutral tweets at a split ratio of 0.8 and 0.9, despite high precision at a split ratio of 0.6 and 0.7. Overall, it shows that the naive Bayes classifier is more reliable in classifying negative and neutral tweets. However, the high precision is probably because of the small number of tweets. Alright, let's jump to the conclusion of our study. So this study basically to present the evaluation of 2 machine learning models for sentiment analysis on smoking perception in Malaysia. The main aim from the sentiment analysis is to see how the thinking of Malaysian on smoking is. The outcome of this paper illustrates the uses of 1-word and 2-word search of the tweets to determine the influence of sentiment in 3 categories, which is positive, negative, and neutral. Naive Bayes and decision tree are feasible method for sentiment analysis, but a lot of improvement is required to improve mainly in the accuracy of the models. In addition, limitation of the datasets is one of the main possibilities of less performance. Perhaps if we can do analysis on the Malay datasets, the performance could be better. Okay, so that's basically it for my presentation today. Thank you.